Hello, my name is Evan Semra. I'm from Matawan High School. I've been attending the Tech Center since September, so I'm a first year here. I'm in the class Advanced Manufacturing. I'm working at a company called FEMA in Portage. They are a all custom work, mainly using robotics to build mainly small engine components. Just being able to go here, there's not a lot of high school students that have the skills and training to be able to take a raw piece of steel or aluminum and make it into a really nice looking part. So I have some skills behind it. And then also in the English that we do here, we learn how to do interviews, and the interviews I definitely think helped me. They made me stand out because the same day I was given a job offer, so there wasn't any waiting, so that means I must have done something right.
Hi, my name is Gabe Kuyers. I'm the Advanced Manufacturing Instructor at the Buren Tech Center, and my program is one of the STEM-related programs at the Technology Center. Students work on anything from manual machines to CNC machines, and then we actually build a 120-pound robot every year and compete with it in a nationwide event. Here are some examples of projects that we've worked on. These are student projects that we cut on the CNC machines. Students also, along with the Herco Machining Center and the Herco Turning Center, learn Mastercam software, and we're running version 7. And so they get to learn everywhere from manual machines all through the machining process and onto CAD/CAM, and learn how to operate that also.
My name is Joel Schmidt. I'm an instructor at the Buren Technology Center. This is my 3rd year here at the Tech Center, and I have the best job in the world. Totally honest with you. I teach the major welding processes here: MIG, TIG, stick, flux core, oxyfuel welding, oxyfuel cutting. I have some CNC plasma projects. I have a welding robot here that I'll let you guys show. We're going to show that too. This is one of the projects that the kids love to do because we got a bunch of kids that are hunters, farmers, so forth. It's a deer head mount, which, like I said, the kids love it. Okay, so now we cleared all our spots, and then what I'm going to do is I'm turning the welder on, put our screen up, and we're actually going to weld with it. And the kid totally designed this. I helped out, the kid totally ran the program.
So we train our students in 3 different programs here. The first being SolidWorks, which is a 3D mechanical program where you can create and edit parts and also machinery. Another one that we use is Revit, which is our 3-dimensional architecture program in which you can create and edit out 3D spaces for homes and also businesses. And the last program we use is Inventor, which is similar to SolidWorks, only it has a couple different capabilities inside of it. So when our students come in every day, they have to grab a time card and they have to fill out throughout the week when they've come in and come out. So they'll line themselves up, punch in and punch out. If they need to take a bathroom break or if they need to go to the office, they have to actually record that. One thing it helps them to do is it helps them to get a feel that this is more of a workplace rather than a classroom necessarily. Gets them a little bit more used to how this works out in the industry. But also it gives me kind of a good record about whether or not they're actually here and how much time they're actually putting in. What I've done in the past is for every hour they put in, they actually earn virtual money, and the virtual money that they have, they can actually use to earn points and earn projects such as use of our 3D printer, use of our 3D scanner, large-scale prints for themselves, or even helping them out on projects that they need some help out on. But it gives them a real-world experience between rewards of actually putting in the time and getting a good work feel for this whole place. Alright, a couple other things we'd like to do in the CAD program here is we don't like to just keep everything on the computer, otherwise it's just a pretty picture and it's no good for anything except for the refrigerator. So what we like to do in here is we like to actually create our parts for real. One way we'll do this is with a 3-dimensional replicator such as this, a 3-dimensional printer called a MakerBot, which can print out 2 different colors at the same time of different parts. In addition to that, we can also use 3D scanning technology that you can see over here to have existing parts reverse engineered. So through these little lasers coming out of the machine here, they can actually three-dimensionally scan an object to a really precise precision, and then we can take it on the computers and do other things with it.
So, my name is Neil Beretsky. I'm one of the students here at the plastics department, and right now I'm running the 3D printer, which right now we've got it programmed in as a dinosaur skull. So as this program is sitting here, what it's doing is it's feeding information over to the 3D printer, and it's laying out the plastic in a very thin layer, about a 10,000th of an inch every time it goes around. And slowly after so many hours, it'll build what you see on the screen here. So this is the 3D printer, the Dimension SST 1200ES. This machine takes the information that was on the computer over there and turns it into data that the printer head can follow. And what it does is it'll sit there and go around in the pattern it's laid out by the computer and lay it out a 10,000th of an inch every time it goes around.
So just like Neil said, you can design and draw anything that you want in this machine. Anything you can dream up of, you can create. This is an actual V8 engine that a student designed in CAD and took to the MITES competition. MITES is a Michigan Industrial and Technological Education Society. Last year we got a grand divisional winner of the whole category of plastics, and this year we got first place in fabricating. So very neat stuff made and created and designed in here.